So in part 2 of our investigation, what we want to practice doing is using the factors to construct a sketch for our graph. And so we learned previously that when we had equations for our quadratics in factored form, we could use those to find the locations of the x-intercepts, and then we could create our form from there. So if we see that our factors are x plus 2 and x minus 1, we could set those equal to 0 to find your x-intercepts. So here, x plus 2, by setting that equal to 0, x would equal negative 2. So we would have an x-intercept at negative 2, 0. And by taking our other factor and setting equal to 0, that would give us an answer of x equaling 1. Our other x-intercept would be at 1, 0. From there, we could plot those points. We could also determine the y-intercept because we know y-intercepts have an input of 0. So we could substitute 0 into the factors, simplify and evaluate to figure out the output for that. So again, if we put 0 in for this part, we'd have 2 and negative 1. Multiply them together, it's negative 2. So we already have 3 points on our quadratic just by looking at the equation. If we do want to look at some graphing features to complete the sketch, this is what it would look like. Here we have an equation of y equals the quantity of x minus 7 times x minus 7. Again, using our previously described steps, we can set each factor equal to 0 to find the x-intercepts. So in doing so, x minus 7 equals 0, solving that, x equals 7. So we've got one x-intercept, and we'll do the same for this x-intercept. And notice how they're the same result. This equation could have also been written as x minus 7 squared. And so we could see that since it's the same factor, we'd have the same x-intercepts. Remember, graphically, what does that mean? That means this quadratic function is not going to go through the x-axis. It's going to touch the x-axis at 7, 0. So if you had your scale of 1 on your graph, we'd be starting here, right? That would be your turning point. And we know that it would kind of come down this way. So we have your decreasing interval and your increasing interval. Could we find the y-intercept? Sure, we could substitute 0 into our function and evaluate it. So if you put 0 into each part, that would be negative 7 times negative 7, that's 49. So again, on this scale, we wouldn't see the y-intercept, but we know where it exists. We also, for envisioning it, seeing where we're at for 7, 0 to get to 0, 49, it's going to be a pretty quick change of rate. So it'd probably be a very thin parabola looking like this. All right, we had one more function to look at, which was y equals x times the quantity x plus 3. So again, we could find the x-intercepts and the y-intercepts to get 3 good points on our parabola, and then use some technology if we need to complete the rest. Our x-intercepts would be at negative 3, 0, and 0, 0. And our y-intercept would also be at 0, 0. So as we saw, if we can write our quadratic equations in factored form versus having them in standard form, we can already determine 3 points on our parabolas that we could plot for a basic framework for our quadratic function, and then we could fill in the rest by generating a table of values or using some technology to assist us.